Hello everyone, welcome to the series of experiment performance on Triple E subject from second year mechanical course concerned with the Savitribai Phule Pune University. I am Professor V.A.Gajdhane, welcomes you all. Today we are going to conduct an experiment number 5, that is the name of the experiment is study of starters for DC motors and three-phase induction motor along with understanding of specifications on nameplates of DC machines. So this is the title of our today's experiment. And what is the aim? We have to study the starters which are required to run the motor in a safely manner, that is the DC motor as well as three-phase induction motor. So for the DC motor we have to study the 3-point starter, and for the induction motor we have to study DOL starter. DOL starter is nothing but the dual on line starter. Okay, and the next aim is what? To understand the specifications on the nameplate of a DC motor. So students, this is a 3-point starter for the DC motors. So the picture of a 3-point starter is looks like this one. We already handled that 3-point starter in the electrical machines lab. The main task of the motor starter is to start as well as stop the motor to which it is allied. Okay, the main task is what? To start or to stop the motor to which it is allied. Actually, starters are used to start the motor in a safely manner. Okay, to start the motor in a safely manner, because the motor is having the tendency to withdraw a large current, initial current at initial time whenever you are starting the motor. So to prevent from such a overload protection, okay, to prevent from such a overload drawn of voltage and current with the help of the motor, we have to compulsory use starter to start the motor. Starters are particularly designed electromechanical switches like a relay that are used to provide an overload protection for the motor. The starters gives the supply to the motor manually or automatically, as well as protect the motor from the faults or overloads, as we already discussed. Based on the type of the motor, the motor starters are available in different sizes with different ratings in the market, because each and every motor is having different types of the specifications. Means it is depending upon the different size and different ratings, because the rating is not similar. The ratings are changed as per the changing of the demand of the customer. So, as per that, the type of the starters are also changed. Here, we will discuss 3-point starter, which is used in a commercial as well as industrial applications. So, the actual picture of the 3-point starter is looks like this one. Okay, and the diagrammatical view of a 3-point starter is looks like this one. What is 3-point starter? A 3-point starter is an electrical device used for starting as well as maintaining the DC shunt motor speed. Okay. The connection of the resistance in this circuit is in series with the decrease the initial high current and guards the equipment against any electrical failure. As I know, I have already said that the tendency of an electric motor is to draw an initial high current. So to prevent from such an electrical failure at initial time, we have to compulsory require a starter. Here, the occurrence of a back EMF plays an essential role in operating the motor, and this EMF extends when armature of the motor starts for rotating in the magnetic field by making the actions as well as opposes the voltage supply. The construction of a 3-point starter. This is the constructional diagram of a 3-point starter. Okay, here in the constructional diagram or circuit diagram, there are the three main points. That's why the name itself indicates that it is a 3-point starter. So, which are the three main points? That is nothing but the point L, okay, which is showing with the help of this arrow. Then point A, and point F. Okay, so the DC motor we're going to see in this part. The DC motor based three-point starter mainly includes the three terminals, namely L, A, and F points. Here, L terminal is nothing but the line terminal. Okay, this L terminal is connected to the line. That's why it is called as a line terminal. It is connected to the positive supply. Okay, here it is also showing in the diagram. It is connected to the positive supply of a DC. A is nothing but means point A is nothing but armature terminal. Okay, this is the point A which is connected to the windings of an armature terminal. This is the armature terminal and it is connected to the armature winding. And F is nothing but it is a field terminal and which is connected to the winding of a field terminal. So this is the F and which is connected to the field winding terminal. The construction of a three-point starter includes a resistance R. Okay, what exactly it includes? It includes a resistance R. Okay, there are some resistances which includes in the construction of a three-point starter, which controls the initial current. Because the property of resistance, we all know that to oppose the flow of current. Okay, that's why they are using resistances over here for controlling the initial current. The H is nothing but the handle in the circuit kept in the off condition with the spring S. So this is the handle. Okay, this is the handle and this is the spring. Okay, this is the handle and this is the spring. So initially kept in a off condition. The handle H can be operated manually for motor operation. At the beginning of the motor position, the motor field windings gets the supply voltage and the armature current is restricted to the particular secure value by the resistance R. Here, initial at the beginning of the motor field winding gets the total supply voltage. Okay, here is the motor field winding. Okay, so initially it will get a full supply voltage and armature current, okay, which is passing through the armature field winding is restricted to a particular secure value by the resistance, because the resistances are connected in series with the armature winding. Working of the three-point starter. So the handle of a three-point starter can be moved from one stud to the another stud, because it is showing in the diagram that is the first, second, third, fourth, and fifth. Okay, so this number actually shows the number of studs. Studs is nothing but the contact position of that handle. Okay, this is nothing but the contact position of the handle. So, three-point starter can be moved from one stud to the other stud, that is the contact position, and this increase the motor of the means speed of the motor till gets its run position. Means we can move the handle from this off position to the run position by contacting to these studs. There are three main points are considered in these positions, which include the following conditions. The DC shunt motor gets a full speed. Second point, the voltage supply in the circuit is straight across both the motor windings and the resistances R is totally cut off in the run position. Okay, the handle H in the circuit is held in a run condition with an electromagnetic strengthened by the NVC. NVC stands for no volt trip coil. Okay, NVC with the help of NVC coil, which is mentioning over here, no volt coil. So this handle can be kept in a run position with the electromagnetic strengthened by the NVC. This NVC coil can be coupled in series with the motor field winding. This NVC actually is coupled in series with the field winding over here. In the incident turned off or dropped below a fixed value, then the NVC will get energized, and by the act of S spring, the handle is released as well and pulled back to its off position, and then it will get pulled back to the off position. As first when a DC supply is turned on by handle clutch in the off position, then handle will move clockwise. Okay, handle will move clockwise direction to the stud 1. Okay, this is to the stud 1, then stud 2, then to the towards the stud 3. Means handle can move in the clockwise direction. The windings of a shunt field is directly associated across the voltage supply, as the total resistance in the beginning is included in series with the armature circuit. Next point, what exactly happens if the voltage supply is unexpectedly disrupted? Then no volt discharge coil is demagnetized, as well as the handle goes to the back of position in the pull of the spring. If no volt coil were utilized, then there will be a supply failure. Okay, the handle H would stay on last step. If the voltage supply is returned, then the DC motor will be openly allied across the supply, resulting in an armature current. If the motor is overloaded, it will draw extreme current from the current supply. Then it amplifies the ampere rotates of the excess release coil as well as pull the armature. Therefore, no volt coil will be short circuited, and this coil is demagnetized, as well as handle H is pulled near the off location by the spring. Hence, electric motor is automatically detached from the current supply. So in this way, 3-point starter prevents the motor from drawing the high current in the initial part of the starting of the motor. So what is exactly the drawback of the 3-point starter? The main drawback of a 3-point starter is it experiences a major drawback of motors by a huge difference of the speed with a modification of the field rheostat. To amplify the motor speed, the field resistance must be applied. So the flow of current through the shunt field is decreased. Whenever adding a high resistance to get a high speed will make the current very low. When NVC is nothing but the no volt coil, is associated in series with the shunt field, then minute current will decrease the power of the electromagnet. Actually, this is the drawback. This magnet may liberate the arm of a handle H through the usual motor operation, as well as detach it from the power supply. Therefore, the 4-point starters can be used where no volt coil is allied in the parallel field. So this is about the 3-point starter. Next is the starter, which is used to start the three-phase induction motor in a safely manner. That is nothing but the DOL starter, that is dual online starter. So DOL starter or dual online starter is a method of starting of a three-phase induction motor. In dual starter, an induction motor is connected directly across its three-phase supply. Here, three-phase supply is given as showing in the diagram, and directly you can connect the dual starter to this three-phase supply over here, and dual starter applies the full line voltage to the motor terminal. Despite this direct connection, no harm is done to the motor. A dual motor starter contains a protection device and in some cases condition monitoring. A wiring diagram of a dual starter is shown in this diagram. Since the dual starter connects the motor directly to the main supply line, the motor draws a very high inrush current compared to the full load of the motor. That is nothing but the 5 to 8 times higher than the initial current. So, the value of this large current decreases as the motor reaches to its rated speed. A direct online starter can be used if the high inrush current of the motor does not cause an excessive voltage drop in the supply circuit. If the high voltage drop needs to be avoided, a star delta starter should be used. This is the another starter which is required to start the three-phase induction motor. The direct online starters are commonly used to start the small motors. Basically, this dual starter, this dual starter is used to start the small types of the motors, especially a three-phase squirrel cage induction motor. Okay, which type of a small motors? Actually, there are two different types of the three-phase induction motor. One is the squirrel cage induction type, and second one is nothing but the slip ring type. But here we have to start the small motors, especially a three-phase squirrel cage induction motor. A direct online starter consists of two buttons, which is actually showing in this actual picture. That is nothing but the green and red. Okay, these are the two buttons for starting and stopping. So the green button for starting and red button for stopping purpose of the motor. The dual starter comprises an MCCB or circuit breaker contactors and an overload relay for the protection. So what exactly it consists of? It comprises of an MCB, okay, main circuit breaker, contactors, this is the contactors, and overload relay protection. This is thermal overload relay protection. These two buttons, green and red, or start and stop buttons, controls the contact over here. So this is about the DOL starter used to start the motor of three-phase induction motor. Next one is the understanding motor's nameplate actually. So this data tells you that which voltage of the motor is made to operate. Nameplate defined parameters for the motor such as power factor, efficiency, torque, and current are at rated voltage and frequency. When the motor is used at other voltages than the voltage indicated on the nameplate, its performance will be affected. So, in each and every motor there is a one nameplate, and this type of a nameplate actually which parameters are mentioned over there, these are nothing but the voltage means operating voltage, then the power factor, then at what efficiency, what is the torque, then what is the highest rated speed, okay, then actually how much is the current required to operate that motor, okay, so these are the, or how much is the power. So these are some parameters which are already indicated on that nameplate. So the motor nameplate is normally located on all produced electrical motors. Understanding the nameplate's information can be hard sometimes, but it is essential. In most of the countries, it is required for manufacturer to display all the informations on the motor's nameplate, but often this is not happens in the case. However, when the motor has been in the operation for a long time, it is often not possible to determine its operating information because nameplates of the motor are often lost or painted over. So this may be happen for some reasons. So what are the details actually they are mentioning in the DC motor nameplates? So the DC motor is nothing but direct current motor which is designed to operate in a direct current. Each motor are manufactured with its specified details. The details of the about the motor is given in the motor nameplate as below. Make CG, that is nothing but the motor is manufactured by the Crompton Greaves. Okay, CG stands for Crompton Greaves. In such a way, you can see some of the motor manufacturers such as Siemens, ABB, IL, EC, Kirloskar, Benz, etc. Next one, M oblique C number. Okay, that is nothing but in this you can find the machine model number. Okay, machine model number. Each machine has its separate model number. Machine number of the DC motor tells us about the design details of the motor. Next one, Reference. This is for manufacturer reference purpose. This number is used to find out the testing details, okay, of this motor. Also, this is the reference number for future spare producement for a same motor. Next one is nothing but the KW. KW is nothing but the, it tells us about that the maximum power that can be supplied by the motor. Okay, KW is nothing but the kilowatts. So it tells us about the maximum power that can be supplied by the motor. Also, it says that motor energy consumption. Next one, frame size. Frame size is nothing but here 132L means height of the motor from footer to the shaft center is 132 millimeter, and L means the core size is a length, in such a way that you can find some other core sizes medium or short. RPM is nothing but this is the speed of the motor. The motor rotates at a 1500 revolutions per minute. Also, you can vary the speed of the motor by changing the armature voltage and field current. Then next one is the insulation class. Then excitation. Then armature voltage means how much is the armature voltage we have to require to operate that motor. Then it is nothing but the duty cycle. Okay. Then the type, it is whether it is a shunt or series. Okay. Then it armature current tells us about the rated current of a armature coil. Then MTG. MTG means mounting of a motor. That is the B3 means footing mounting. Okay, so these are some standard dimensions which they have printed on the nameplates of the motor. Then bearing CE, it is same like an induction motor, that is the DE and NDE. Okay, here CE means the commutator end, and the commutator side motor bearing number is 62606 2RS. Non-commutator end ring bearing number is nothing but the 63062 RS. These are the standards which they have mentioned over here. Then the field voltage actually and field current. Then protection, protection from the dirt, dust, and the other non-corrosive materials. Then cooling IC, the fan cooled motor which cools the stator as well as the rotor of the machines. They were also mentioned here. So these are some important parameters they are mentioning on the name plates. So students, finally from this study experiment, we have concluded the study of different types of the starters for DC motors as well as repeat induction motor, and the specifications on the nameplates of the DC motor. Thank you for watching this video.